Good evening, everyone. Welcome back to day 3 of domain analytics. So far we have taken a look at applications of ML and AI. And we have taken them in look at with the context on securities analysis. And then we covered CRISP MLQ and we covered ML primer. So with these two topics done, we move on to the next topic, that is EDA and pre-processing. So EDA stands for Exploratory Data Analysis. So you are taking the historical data and you're performing exploration on it. You're trying to understand the data. You're trying to understand that data better. And because of this, we can make some derivations out of it. So that will be our agenda for the day. So what we are going to cover is exploratory data analysis and pre-processing. Now, exploratory data analysis can be of three types. You can have univariate, bivariate, and multivariate. So, as the name suggests, uni, bi, and multi. So, univariate means when you're analyzing only one variable. And bivariate is when you're analyzing two variables. And multivariate is when it's three or more variables. So when you're doing exploratory data analysis, you will come across these three terms. So that is the basics of EDA. So we'll see how we can perform EDA on a data set. And then we'll also take a look at data pre-processing. Okay, so the first thing that we do is we understand our pre-processing. Now, pre-processing is the second step of EDA. So in pre-processing, we have different ways we can do pre-processing. So the first, before we get into pre-processing, there is, however, something I'd like to talk about for a few minutes. Okay. And that thing is what we call as continuous and discrete variables. So continuous variables are variables that can be in decimal format. So that is the basic of continuous variables. So wherever you have decimal format, you can have that. All right. And then discrete is where you cannot have not be in decimal format. That means these values cannot be represented in decimal formats. Okay. And in continuous, we have count. Count is basically counting. If you are counting, for example, the number of students in a class, that would be called as count. And categorical. Categorical is non-numeric data. All right. So this is continuous and discrete. Now, moving forward, we'll take a look at the first variable that is called typecasting. Typecasting means changing the data type. Basically, it is conversion of data type from one format to another format. Okay. So in typecasting, let's say, for example, you have some value. Let's say, for example, let's take a look at this. If we compare ISD to INR to USD. So if we keep a dollar here, it would be 80.02. Now, so 1 USD equals to 80.02 INR. This 80.02 value is a float value. In Python, we call this float. Okay. So typecasting would be, if you have a variable, let's say declared 80.02, you can convert this variable to 80 without any decimals. When you convert anything to a number, when you convert a float value, this is a float value and this is an int value. So this is called typecasting. Similarly, you can convert this 80 value to a string. You can also make it a string. So this is typecasting. Typecasting is basically changing the data type of anything, any object we are working with. So you can also convert then this 80 string back to int, and then you can convert it back to float. But when you convert, if you have a string, if you have an int value here, 80 equals to x equals to 80 with int value, when you convert it to float, this becomes x equals to 80.00. So this does not retain its 0.2. So that is something you have to keep in mind whenever you're performing typecasting. If the decimal value is important, maybe you want to, instead of using x, you can maybe use x1 or x2, something like that. Okay. So that is typecasting. Then you have duplicate values. Duplicate values are repeated information. Okay. So basically in duplicate values, you have the same values being repeated again and again. So let's say, for example, this is a data set that we are working with. So let's say this is some column name, age, gender, and salary, let's say. So name is X, age is 25, gender is male, salary is 20K. Then you have Y, age is 30, gender is female, salary is 40K. Then again you have Y, age is 30, gender is female, and salary is 40K. So when you have a situation like this value is duplicated. So whenever you have duplicate values, you simply remove them. You remove these duplicate values. Okay. Because having duplicate values within a data set is a problem. Okay. So instead of having duplicated values, we try to remove them. And that is how we treat it. We remove them because they might add bias to our model. Because if you have a lot of duplicated values, they will make the model think that this specific values are important. Okay, so we remove them. All right, so that is duplicated values. Then we have outlier treatment. Now, outlier is very important. Outlier means anomaly in the data. So for treating outliers, we use something we call as box plot. This box plot gives us information on whether there is a presence of outliers or not. So let's say, for example, we have this line that represents our data. So here we have something we call as Q1, Q3, and we have this Q2. This Q2 refers to the median value, the middlemost value of the data set. Okay. Q1 is the first quartile and Q3 is the third quartile. So first we calculate something we call as IQR. IQR is inter quartile range. Okay, so we have IQR. IQR is calculated as Q3 minus Q1. Okay, so you calculate Q3 minus Q1. After getting this IQR, we draw something we call as fences. These fences are like boundaries that split the data between outlier data and non-outlier data. So you draw these boundaries on either side. You draw them here and you draw them here. Okay. So now let's say we have this left fence. How do we draw this left fence? We'll call it, what do you call it? Let's say left fence. How do you draw this? This is drawn as IQR minus 1.5 times of Q1. Okay. Similarly, you have right fence. Right fence is written as IQR plus 1.5 times of Q3. So here, let's take an example of salaries. So you have a salary data set for a company. You have about 1,000 entries. So the lowest 5 salaries we have are 10,000, 5 times. And the highest salary we have is, let's say, 10 lakhs. Then we also have 9 lakhs and 8 lakh. The median is about 60,000. So this Q1 value is, let's say, for example, 30,000. This is 80,000. Okay. So that is the range. So IQR in this context would be 50,000. Okay. So then we calculate the left fence. That would be 50,000 minus 1.5 of 50,000. So this becomes minus 25,000. So this fence value is minus 25,000. Similarly, you can calculate the right fence. That would be 50K plus 1.5 times of 50K. So this becomes 1.25 lakh. So this value is 1.25 lakh. Now at the lower end, we don't have any outliers. Okay. This 10K salary, it will lie somewhere here. Okay. But you have this 8 lakh salary, 9 lakh salary, 10 lakh salary. These values are lying outside this right fence. Okay. And because they are lying outside the right fence, we can call them as outliers. Okay. So this is how you find out outliers within a data set. Now, once you have found the outliers, you also have to treat these outliers. So treating these outliers is also an important process. Okay. So let's take a look at it. So you have Vincerization, and trimming. Okay, first you take a look at this 3R technique. You either rectify the outliers, that means you correct the outliers. You can retain the outliers. There might be a scenario where the client you're working with says that I don't care that we have outliers, we can retain them. And then finally, you can also remove these outliers. That means you simply get rid of them. Okay, so then let's take a look at rectify and remove. All right, so to rectify outliers, see, we do something called Vincerization. We do Vincerization. Now this Vincerization means putting the data between some bounds. For example, let's say you're doing 90 Vincerization. Let me write it in the middle. So you have Vincerization. So Vincerization, let's see what it means. Let's say you do 90 Vincer. Okay, so let's say if you want to do 90 Vincerization, what you will do is you'll calculate the 5th percentile value, and then you'll calculate the 95th percentile value. Okay, so let's say that this is our 5th percentile and this is our 95th percentile. Okay, and we have some data that exists outside these percentile values. There are some values that are less than the 5th percentile, and there are some values that are greater than the 5th percentile. So what we do here is we simply transform these values. So let's say these outlier values are ranging from 100 to 200. 5th percentile value is 250. These values are ranging from 960 to 1000. 95th percentile value is 950. Okay. So what we'll do is we'll transform these values. We'll simply transform them. So these values, they will also become 950. These values, they will become 250. So in that way, you're removing 10 percentile values. So you're left with 90 percentile values. Okay, you're not removing the data points, you are transforming the data points to the 5th percentile and to the 95th percentile. Similarly, you can also try with 10th and 90th. That would be called 80 Vincerization. Okay, and then moving forward, we have something we call as trimming. Trimming means removing the data. In this, we are completely removing the outliers. We are not applying any sort of rectification on them. We are simply removing them. Okay. So again, if we go back to our example, you have the 5th percentile, you have taken the 90th percentile. You have defined these bounds that any value outside these percentile values should be removed. So you have these data points from 100 to 200. You have 250 here. You have, this is the 95th percentile, sorry. You have 950 and you have these values 960 to 1000. What you will do is you will simply delete these data points. You will simply delete these data points. You are not retaining them. You are not rectifying them. You are not doing anything. You just are removing these outliers. Okay, so that is what we call as trimming. So these are the two ways in which you can handle outliers. Okay. And then we have zero variance or near zero variance features. What this means is, if you have a column for country and the entire column is India, all the way to the end, India, there is no variation in this column. There is no differentiation in this column. Everything is the same. Okay. So when you have a situation like this column is not adding any information. Okay. And because it is not adding any information, we can simply remove it. All right. Because these columns are very important when you're doing ML model building. So you simply remove them. So then moving forward, we have discretization, binning or grouping. Discretization means converting continuous data to discrete data. Now this is not the same as typecasting. In typecasting, we are changing the data type. Okay. In that also we can convert float values to int values, but that is not what we are doing here. Okay. So let's see, you have binarization. Okay. Binarization, as the name suggests, you are converting the data into some binary format. Yes, no, true, false is what we call as binary format. So let's say you have salary. Again, you have salary 10,000. You have salary 1 lakh. The median is something like 45,000. And the mean is 50,000. Okay. So what you can do is you can take the lowest value. You can define a range. Lowest value would be from 10,000 to 50,000. Make it low salary. From 50,000 to 1 lakh, make it as high salary. Okay. So here you want to take 1 lakh 1. Why? Because in Python, the range, this would become from 10,000 to 4,999. So there is no overlap. So now you had numerical salary data, and now it has been converted to a binary format where it is saying low salary and high salary. So that is the formula for doing Binarization or binarization. Okay. So then moving forward, you have rounding. Now rounding is also converting float values to int values. Okay. But there is a big difference when we do the rounding. Okay. So you're rounding the float values to its nearest integer. So let's say, but before we understand rounding, let's understand a couple of things. In mathematics, we have something called floor values and ceiling values. Now floor values means if you have x equals to 2.4, if you take the floor value, this will become 2. If you have 2.7 and you take the floor value, it will become 2. Okay. And that is what is happening when you're doing typecasting. In typecasting, these values are going to the floor value. Now, if you are taking ceiling value and you have x equals to 2.4, then this will become 3. 2.7, this will also become 3. If you have defined that you want to take the ceiling values. Okay. So floor and ceiling. So let's say you have x equals to 2.5. Okay. Now what happens in typecasting? This becomes 2. What happens in rounding? X becomes 2. Okay. But what if you have another variable y that is 2.51? In typecasting, this becomes 2. In rounding, this would be 3. So in rounding, based on where that number lies on the number line. So for example, you have this number line, you have 3, and this is your 50% value. Anything that is on the 50% value or lower will go to 2. Anything that is after the 50% value will go to 3. So that is rounding. And finally, you have binning. Binning means creating groups. Okay. So binning means creating groups. You're creating groups within the data set. So again, going back to our salary example, you have 10,000 to 1 lakh. Okay. So what we do in binning is we say that instead of having only low and high salary, we also want medium salary, mid-range salary. So what you can do is you can define some range. You can say 10,000 to 30,000 should be low salary. 30,000 to 65,000 should be medium. And then 65 to 1 lakh 1 should be considered as high salary. So instead of having 2 groups, now you have created 3 groups. These 3 groups, you can use it further on when you're building your ML model. But essentially you had some continuous values. These were all continuous values. And now they have been converted to discrete values. Okay. So that is what we do in binning. And then you have missing values. Missing values are represented by NaN in Python. So whenever you open your data set and you see these missing values, NaN values, that means you have missing values. So what happens in missing values? In missing values, you do imputation. Okay, you do imputation. Imputation can be of 3 types. You can take the mean, median, or you can take the mode. All right. So in mean, you're taking the average value within that column and you're replacing NaN with it. So simple procedure, you're simply calculating the mean and you're replacing the NaN values with it. Now the disadvantage of mean is that it can get disadvantage. It can get affected by outliers. All right, it can get affected by outliers. And then here you're taking the middlemost values. So here, again, you're replacing this NaN values with the median. And the advantage of this is that it does not affected by outliers. All right. So that is the advantage of median imputation. Now mean and median imputation, mean plus median imputation can only be done on numerical data. Obviously, you cannot find out the average value for a string, right? So that is why we do it only for numerical data. So when you come to categorical data, we use mode. Mode can be done both on numeric values as well as categorical values. Okay. So here you're finding the most frequent values. You find the most frequent values and you replace NaN with it. Okay. So this is missing value treatment. And then we have dummy variable creation. Dummy variable creation is replacing categorical data with numbers. Now, in Binarization, we had converted continuous data into discrete data, and discrete data and categorical data is part of discrete data. So why did we do that? To reduce the total number of unique entries we had. Now what we have to do is, after we reduce that unique entries, we have to get into replacing the categorical values. So in this, we can do one-hot encoding, and we can do label encoding. So in one-hot encoding, categorical values are replaced by zeros and ones. Okay. So for example, you have some value by shares, and the possible answers here are yes, no, yes, yes, like that. So if you do one-hot encoding, it will create two columns: by shares, yes, and then by shares, no. So this becomes 1 0 0 0 1 1. This becomes 0 1 0 0. All right. So when you are doing one-hot encoding, you can also ask it to remove the first column. So this removes this by share yes column, and you are left with by share no column, where 0 means yes and 1 means no. So that is how we do one-hot encoding. Now, if we have more than one column, more than two outputs within a categorical data, you can expect that many columns. For example, you have 5 values. You can expect 5 columns. Okay. But in label encoding, what happens is it replaces the values with some numerical output that is ranged between 0 and n. N is the total number of unique values you have. So if you have two values within one column, you will get 0, 1, 0, like 0, like that. If you have more than two values, let's say if you have 5 values, you will get 0, 1, 3, 4, 0, like that. So that is label encoding. Okay, so you can try either label encoding or you can try one-hot encoding. Now label encoding, the disadvantage is that because it is only creating a single column, the machine sometimes might assume these labels as ranks. Okay, so you have disadvantages to both. You have disadvantages to both. What do you call it? One-hot encoding and label encoding. So you can pick either of them. And then we have transformation. Transformation is basically changing the data. So for example, in transformation, you might apply logarithm. You can apply square root. You can apply exponential. So these will change your numeric columns in some ways. So whenever you apply transformation, you are changing your column pattern. All right. So this is transformation. And then finally, we have standardization. Or normalization. So standardization and normalization is used to make data scale free. Now, there are three ways in which we can do standardization and normalization. The first way is called standardized scaling. In this, you find the mean as well as the standard deviation of the data. Then what you do is you take the summation of I equals to 1 up until n. You take x of I minus the mean and you divide it by the standard deviation. So this reduces large number of this reduces the larger scale of data to a very small range of data. So important point to keep in mind when you apply this standard scaling. After applying this standard scaling, your mean should be 0 and your standard deviation should be 1. Okay, so this is something you have to keep in mind. All right, now there might be a scenario that when you are applying this standardization, your mean might look something like this: 1.60 e to the power minus 17. That means there are 16 zeros present before 1. Okay, so that is near 0. So in case you see your mean like this, don't panic. Okay, and then we have min max scaling. So in min max scaling, what you do is you find the minimum value, you find the maximum value, you find the min and the max. Then you subtract again x of I minus the minimum value of I divided by max minus min. So this is the formula for calculating min max scaling. Okay, now After you apply min-max scaling, your number range is reduced to being between 0 and 1. Okay, so this is standardization or normalization. Then you also have a few string operations. So in string operation, you're basically converting your string into different formats. So this is data preprocessing. Finally, we have EDA, exploratory data analysis. In this, we have 4 business moment decisions. The first business moment measures the central tendency of the data, how centralized the data is. In this, we calculate the mean, median, and mode. Then you have the second business moment decision, which is basically how spread apart your data is. In this, you calculate variance and standard deviation. And remember, standard deviation is nothing but the square root of variance. Then you have the third business moment decision, which is the skewness. Skewness measures the asymmetry of the data, how asymmetric the data is. Okay, so in skewness, it is telling you, is the data concentrated in the middle, on the left or the right of a histogram. And then you have fourth business moment, which is kurtosis. Kurtosis tells us the peakness of the data. It is measuring how the peak of the data looks like. Okay, is it peaking a lot? Is it having thin tails or no? And then you have graphical representation. Graphical representation is something we have already covered. So in graphical representation, you are taking the univariate, bivariate, and multivariate. So let's take a look at a few examples. Univariate is bar plot, dot plot, histogram density plot, box plot, QQ plot. Bivariate is scatter plot. Multivariate is pairs plot or interaction plot. Okay, so that is EDA and preprocessing. Now let's take a look at a code and we'll see how this works in real life. So here we have a few libraries. So let's take a look at quickly what these libraries are used for. Pandas is used to work with data frames. NumPy is used for numbers as well as working with arrays. Matplotlib is used for visualization. Similarly, Seaborn is also used for visualization, but this can also do 3D visuals. So that is the advantage of Seaborn over Matplotlib. But we can use both. So let's start. So this will import pandas, NumPy, and Matplotlib and Seaborn. Okay, so we'll start with this. We'll import our libraries. We'll import our data set. Meanwhile, let's also take a look at the data set. So the data set is giving us portfolio prices of different companies. So security wise, price, volume data. So you have lakhs of entries here, and these entries are going to give you the closing price, the highest price, right? The average price, turnover, delivery per quarter. So all these things you are going to see. So we'll use this data tomorrow for a ML model, but for now we'll apply pre-processing on it. So let's take a look at the data types. The data types we have object and float 64. Object is nothing but string, and float is numerical data. Okay, so what we'll do is we'll take a look at the shape of it. We'll look at the first 5 rows. So we can see what all options we have. We'll take the symbol. Okay, we'll take a look at the column names. All right. And then I'll come back to this cell in a bit. First, we'll check for null values. Then we'll drop these null values. Similarly, we can also check for duplicate. So we can see that we have 35 duplicated values. So we'll say df equals to df dot drop duplicates. But before we do that, let me just run this cell. So this cell, this pandas profiling, we use it for auto EDA. Now auto EDA will perform basic EDA for us. It will look at the data set and it will perform basic EDA. Okay, so it will, what do you call it? Oh, wait 1 minute. Let me just run this again. Then we'll take a look at auto EDA. So let's start. So up until auto EDA will run it. So in auto EDA, it will go through your data sets and it will do the 4 business moment decisions. It will do some graphs as well, basic graphs, not very intuitive, basic graphs. All right. It will also draw some, correlation metrics to see what is the correlation between data sets. Okay. It will also tell you about missing values. It will give us some information about duplicated values. Okay, so these are basic Eda and pre-processing steps, and these steps will be performed here by auto EDA. Okay, so we don't have to do it. So auto EDA is definitely something that people should explore. Okay, so let it let it generate the report, and then we'll take a look at the report. So it has generated an HTML file that we can open. So here we can see how many variables we have, what are the total number of observations, how many missing values we have, how many duplicated values we have, what are the variable types, are they categorical or are they numeric, and then we can explore the variables. So here we can see that within the symbol we have some missing values. Most of the missing values are within, there are no missing values in this symbol. Okay, you can also explore this, see what it is. You can look at the categories. Okay, you can see which names are being repeated the most. Okay, you have ECL Finance, IRFC, HUDCO, NHAI. Okay, so you can take a look at all these values. You can also take a look at IDFC Bank, for example, here. So this is with relation to symbol. Then you have series. Series is where we have most of our missing data. Okay, so again here You can take a look at the details, and here you can actually see equity, what type of what do you call it? It is what type of stock it is. So you can see that EQ and EQ are the highest. Okay. So you have the same values being shown twice. So they are taking up more than 80% of the data set. All right. And then you have date 1. So this is showing the date. You have a total of 620 values. Okay. So you can see the frequency of the dates. All right. And then you can take a look at the price. This price is depicting the previous closing price. So here you can get the quantile values. You are getting the 5th percentile value. You are getting the 95th percentile value. You are getting the max min range. You are getting the IQR. You are also getting the Q1 and the Q3 values. You are also getting the median. Similarly, you are also getting the standard deviation, the tosses, mean absolute deviation, skewness, the sum, and the variance. So all these basic steps we had already seen. So you can calculate them. Similarly, they have drawn us some histogram. So we can take a look at this histogram. Not very useful. Okay. We can also take a look at the most common values, and we can also take a look at the least common values. All right. Similar things we can do for open price. We can take a look at all these descriptive statistics. So for numerical data, you will get the quantile statistics, and you will also get the descriptive statistics. So you keep moving on: high price, close price, average price, TTL, TRD quantity, turnover in lakhs, delivery quantity. Okay. So it will also give you the total number of distinct value, delivery per quarter. Okay. Then you can also see the interaction plot. Now, if you remember here, interaction plot is a multivariate analysis. So you go here, previous close to open price. You can see how they're interacting with each other. Average price. Okay. So you can see all these interactions for all the numerical columns. Then you can take a look at the correlation. In correlation, you can take a look at Spearman's, Pearson's, Candle's, Phi. So you can see here using Pearson's that we have basically perfect collinear relationship between 5 of our columns. Okay. And the rest of them are displaying very low correlation. So maybe that is something that we need to keep in mind. Any way you take, you can notice that the correlation is very high. All right. And then you can also take a look at the missing value. So you can see how many missing values are there. 1. And it is also going to give you the row number. Okay. So this is the first rows, last 10 rows. And then you can also take a look at the most frequent duplicate rows. Which rows are being occurred in a duplicate manner most frequently. Okay. So this is what we do in auto EDA. All right. So you can take a look at the alerts. It is going to give you some alerts, and also take a look at reproduction, how long it took you for it to get all these values. All right. So moving forward, we know we have missing values. So we'll drop all the missing values. We know we have duplicate values. So we'll drop all the duplicated values. Okay. We'll apply the normalization function. We'll take describe. We'll see the mean is very high. The standard deviation is very high. These things we already know. We'll create a new variable where we are taking all the numerical variables. We are taking a look at all these numerical variables, and then we apply the normalization function. We have applied min-max scaling. When you apply min-max scaling, the range is reduced between 0 and 1. Okay. So we'll do this and we can take a look at the range. Minimum and maximum. It's 0 between 0 and 1. Similarly, you can also apply standard scaling. We can declare a standard scaling variable. So we'll create a new variable where we apply the standard scaling, and then we'll say and we can take a look at our standard scaled data. Okay. So this is what a standard scale data would look like after we convert it to a data frame. So then what we can do is we can do the describe call. So when we do the describe call, you can see that while the mean is showing some numerical values here, these numerical values are very low. They are basically so small that we can assume that they are 0. And again, the standard deviation is 1. It is 1 everywhere. Okay. So this is what we do in EDA and pre-processing for a data set. So that is all we are going to cover today. So thank you everyone for joining, and I hope you had a good session.